There was a moment, sometime around 2018, when a fisherman in the Yellow Sea pulled up his net and found almost nothing in it. Not less than before. Nothing. He had been working that stretch of water for over 30 years. His father had worked it before him. And in that time, the sea had changed so completely that it no longer resembled the place either of them had known. The crabs were gone. The seagrass was gone. The water itself had a different color, a heavy, greenish murk that rolled in from the shore like something sick. What happened next surprised even the scientists. Because within a few years of a single, almost absurdly simple intervention, that same stretch of coastline began doing something that nobody had predicted. Not the marine biologists, not the government agencies who authorized the project, not even the fishermen who had spent decades watching it die. This is the story of one of the most unexpected ecological turnarounds in modern history. And it did not happen in a rainforest. It did not happen in a protected wilderness. It happened in one of the most heavily industrialized, most densely populated coastlines on the planet. The Bohai Sea along China's northeastern coast was not always a dead zone. For centuries, it fed entire provinces. Fishermen pulled in hauls of Chinese mitten crabs, a species that had defined the regional ecosystem for longer than recorded memory. The mitten crab is not just a food source, it is an engineer. It burrows into sediment, aerating the sea floor. It filters as it feeds, turning over organic material that would otherwise rot into toxic sludge. It is prey for dozens of species above it in the chain, and predator for dozens below it. Remove it, and you do not just lose a crab. You pull a keystone from an arch, and the arch collapses. Collapse is exactly what happened. Through the 1990s and into the 2000s, a combination of overfishing, industrial runoff, and coastal development dismantled the Bohai ecosystem piece by piece. Trawlers scraped the floor clean. Factories along the high river system discharged nitrogen and phosphorus into the water at levels that triggered algal blooms so thick they blocked sunlight from reaching the seagrass beds below. The seagrass, deprived of light, died. The sediment, no longer anchored by root systems, became fluid and unstable. The mitten crab population, already hammered by fishing pressure, lost what remained of its habitat and cratered. By the early 2010s, surveys were returning numbers so low that some researchers debated whether local extinction had already occurred. This was not a slow decline. It was a cascade. One thing failing, triggering the next, until a living sea became something closer to an open drain. The question researchers at the Chinese Academy of Fishery Sciences were asking by 2015 was not whether the ecosystem was damaged. That was obvious. The question was whether the damage had crossed a threshold. Whether the system had what ecologists call a tipping point, a state it had locked into so completely that removing the stressors would not be enough to reverse it. Some ecosystems, once they flip, do not flip back. They just stay broken. The answer required a gamble. If a story like this gives you hope, comment the word hope so we know you're watching. The decision to reintroduce Chinese mitten crabs into the Bohai coastal zone was not universally celebrated. Critics pointed out that introducing large numbers of animals into a degraded environment can accelerate collapse rather than reverse it. If the habitat cannot support them, the animals die, their decomposing bodies add nutrient load to already overnutriented water, and the bloom problem worsens. You have not helped. You have spent resources making things worse. The counter-argument, and this is the part that is easy to miss, was not that the habitat was healthy enough to receive them, it was that the crabs themselves were part of what made the habitat healthy. You could not restore the seagrass and then introduce the crabs. The crabs were part of the mechanism that restored the seagrass. The causality ran both ways. The ecosystem was not a ladder you could climb rung by rung. It was a web. You had to reintroduce the web all at once, or close to it, and then watch what the web did. Between 2016 and 2020, in a phased program coordinated across multiple agencies, researchers and local fishery management bodies released millions of juvenile Chinese mitten crabs into targeted sections of the Bohai coastline. The headline number that circulated in later coverage was approximately 10,000 kilograms of juvenile stock across the program's peak years, a figure that translates, depending on the life stage of the animals, to somewhere between several million and tens of millions of individual crabs. The releases were not random. They were mapped to areas where sediment, composition, and remaining water quality gave the juveniles the highest probability of establishing. And then they waited. The first year returned ambiguous data. Survival rates were difficult to measure in open water. Researchers placed monitoring stations at intervals along the release zones, tracking water turbidity, oxygen levels, and sediment stability. The early readings were inconclusive. Some sites showed modest improvement, others showed no change. One showed a short-term spike in nutrient levels that briefly alarmed the team. The second year was different. What the data showed was not a gradual improvement. It was a threshold crossing. In several monitored zones, sediment aeration levels jumped in a way that correlated directly with burrowing activity. Where the crabs had established in sufficient density, they were physically turning over the seafloor. The effect on turbidity was measurable within months. Water clarity in those zones improved. And with improved clarity came something that had been absent for years: light reaching the bottom. Where light reached the bottom, seagrass began to return. This is the part that surprised even the scientists. Not that the crabs survived, not that they had some impact, but the speed. Seagrass recovery in marine environments typically takes a decade under favorable conditions. In monitored sections of the Bohai project zones, early recolonization by seagrass species was documented within 2 to 3 years of crab establishment. The data was undeniable. The crabs were not just surviving in the ecosystem, they were rebuilding it from the inside. And once the seagrass returned, the cascade ran in reverse. Seagrass beds are among the most productive habitats in coastal marine environments. They provide nursery cover for juvenile fish. They stabilize sediment at a scale no burrowing animal can match alone. They absorb carbon. They produce oxygen. They create the structural complexity that allows dozens of species to coexist in a patch of water that would otherwise be open, featureless, and functionally dead. When the seagrass came back, it brought everything that lived in it. Small fish, then larger fish, then the birds. The fisherman from the opening of this story, the one who had pulled up an empty net in 2018, reported his first meaningful crab catch in years by 2021. He was not alone. Surveys across the Bohai restoration zones documented recovery in mitten crab catch rates that defied the projections researchers had built from historical decline curves. The system was not just stabilizing. It was accelerating toward recovery in a way that the models had not predicted. No one expected this. There is a concept in ecology called a positive feedback loop. Most people encounter the term in its negative form. A warming climate melts permafrost, which releases methane, which warms the climate further. Runaway collapse. But positive feedback loops exist too. A recovering seagrass bed stabilizes sediment, which improves water clarity, which allows more seagrass to grow, which stabilizes more sediment. Recovery feeding recovery. The Bohai reintroduction had not just added crabs to a broken system, it had found the entry point for a positive feedback loop that the system itself was capable of running once given the initial push. That is the part that changes how you think about restoration. The assumption built into most environmental pessimism is that damage is easier than repair, that it takes less to break something than to fix it. And in most human-made systems, that is true. But living systems have a property that engineered systems do not. They want to be complex. Complexity is the attractor state. Simplicity in a living ecosystem is the aberration, the trauma response. Given even partial conditions to recover, many ecosystems will move toward complexity on their own. They do not need us to build them back from scratch. They need us to stop breaking them long enough to find the thread. The Bohai project is still ongoing. The restoration is not complete. The high river inputs that triggered the original bloom problem have not been fully addressed. Fishing pressure in the broader region remains significant. There are zones where recovery has been slower than hoped and problems that one species reintroduction cannot solve alone. No one involved in the project is claiming victory. They are claiming something more careful and more important. Evidence that reversal is possible, that the threshold had not been crossed permanently, and that the right intervention at the right point in the web can set a cascade running in a direction that surprises you. For that fisherman on the Yellow Sea, pulling up a net with crabs in it again, the science is secondary. What matters is that the sea looks different now. The water is clearer in the restoration zones than it was 5 years ago. He can see further into it from the side of his boat. He noticed it before the researchers published anything. The sea told him first. That is what these projects keep returning to, across every story this channel has covered. The moment when the numbers on a scientist's spreadsheet and the lived experience of someone who grew up next to the land or the water arrive at the same conclusion from completely different directions. The data confirmed what the fishermen already sensed. Something down there was alive again. If you believe nature still has a chance, subscribe. Your support keeps these stories coming.